Ji Daniel, how are you?
I'm good, ma'am.
You're,
Sorry for joining late.
क्या हुआ था?
Uh, I slept late and wasn't able to wake up on time. Sorry.
Okay. We um. Okay, you can continue, Wasil. You need to share your presentation.
Is the slide visible?
Yes.
And am I audible to everyone?
Yes. Yes.
We have come to the chronology of the universe. How chronology means how finding out the dates and how the universe has formed, when the universe has formed, or what is the time period. There are various methods, but here it is a method of radioactive decay and the study of where the elements and life cycles of elements and the daughter nuclei. And by studying their decay rate, we can find out the age of certain elements. For example, the earliest elements on Earth date back to about 4 to 5 gigayear. 1 gigayear equals 1 billion years. So our Earth is 4 to 5 billion years old, and it has been proved. So this way of knowing the age of something is very fundamental in understanding the age of anything that we apply it to. So this formula AU equals sigma plus delta plus AE, where sigma is the condensation of first galaxies and stars. Means that how much time it took to form the first generations of stars and galaxies. Its value is constant about 1 to 2 giga year, and delta is the time interval for the present chemicals to be formed. What chemicals, what elements we see today were formed, as I said earlier, were formed in the core of stars. So how much time it took for the chemicals to be formed from individual elements to chemicals. Delta is that, and AE is the age of the Earth, and it has been found out that age of the Earth is about 4 to 5 billion years old. So this formula gave a precise calculation, and from this method we have found out that age of the universe is about 14 plus or minus 2 giga year. Means that the universe is about 14 billion years old, and uh, we can see through our telescopes the further uh, we can see is 14 light years back. There are objects and that we can observe uh, in vast in far corners of the universe that the light takes for that much amount of time, 14 light years, 14 billion light years to reach us, is what proves that yes, these calculations might be precise. There are some uncertainties in the values, but uh, uh, talking about the universe, just we have just started to understand the universe. So these uncertainties are there, and we cannot do anything about them. But they give more or less right answer to be used in the calculations. So the universe has been dated back to 14 billion years of age. Moving on to the next slide. So in our modern day, recently a telescope has been launched into space named the James Webb Space Telescope. It has been manufactured only to see the infrared spectrum of the electromagnetic light, electromagnetic spectrum. So what this means is when the universe was formed, and as the cosmic microwave background have suggested that the radiation that come from the early stages of the universe still reach us, but they are in the infrared spectrum of the electromagnetic spectrum. So prior to this telescope, the James Webb, uh, we had no telescope that can uh, look in the infrared spectrum. So now we have placed a telescope in the space that can do that. So this is a step into the future, as it is a very core. That would be a very core discovery to find out that what happened in the early universe through this telescope, as it can explain how these radiations how these radiations affect each other, and uh, how its effects are today. And prior to this, the Hubble, there was Hubble telescope. It is right there, and it is there right now, but it has, you can see here, it's very limited to a spectrum which is from ultraviolet to some visible light to some infrared. But what here we can see the James Webb. It is completely uh, technically built for this type of wavelength, the infrared. So it will unravel some mysteries of the universe, surely. So in understanding the cosmos and its vicinity and its vastness, we have only just begun to understand it. So there are bunches of mysteries to be unlocked, and we have about understood the universe about 1 to 2%. Everything other than that is still a mystery. For example, the black holes. What's beyond the black holes, or what the dark matter is, what the dark energy is, what is dark gravity. So in expansion, as I have said earlier, in expansion, the dark energy make the expansion accelerate. So there might come a time that all the stars and all the galaxies and everything in it has moved so far away from us that even light cannot reach, even their light cannot reach us. So that is a phenomena that is going to happen in the very far future, that everything goes away from us. We cannot see anything but dark void of the cosmos. So yeah, these facts are somewhat disturbing, but yet uh, we might be able to do something about it, or might find out how to create wormholes. Wormholes are space gateways through which we can travel. It's not technically possible yet, but in further future it might be possible. Uh, its uh, theory is there, but the engineering, it's an engineering problem right now. Theoretically, it can be formed, but our technology has limited us at this very stage. So yeah, the universe is expanding into something further. We don't know yet in what thing it is evolving or expanding into. So the end of the universe, we might say, will be as the universe is expanding infinitely into into something that the universe will end in a cold dark universe. So, yeah, these are all disturbing facts, but it's in the very far future. So we need not to worry about it right now. But it's going to happen. It's a fact as the universe is expanding. Rather, if we find out and if we can somehow make the universe, make the expansion of the universe decelerate somehow, uh, that's a thing that can be happened, but it's not possible right now. So yeah, thank you. This was all from my side. Any questions?
Yeah, thank you, Wasil.
Thank you, ma'am.
So, questions, please.
Hello, Wasil. I
Yeah.
have questions. So,
हमसे
what-
चलो
yes, ma'am.
मेरे मेरे भी ठहरो एक मिनट. आपकी आवाज नहीं हमें सही आ रही थी.
अभी आ रही है, मैम?
आप बाकी लोगों को आ रही है?
Yes, ma'am, Ari.
अच्छा ठीक है, बोलो.
Yes, ma'am, आ रही है.
बोलो बोलो.
Wasil, the first question is that, first of all, you have beautifully explained the branches of physics. So, my question first is that, would you like to give us us about the dark energy and the dark matter? And the second question is that, as we all know that the the matter is the form of energy, and you have give us some idea that our sun has fusion and fusion reactions, and we know that this is not ending reaction. So, would you like to give us a rough estimate that when our sun will stop to give us energy?
Okay, so yeah, your first question was what is dark energy and the dark matter, yeah?
Yes.
So we don't actually know what dark energy is and dark matter is, but only we observe its effects. So we just gave it a name, dark energy, dark matter. We could name it even. Uh, these are just names. So we don't know what it is, but its effects. For example, there is dark gravity also, which can attract objects towards itself, but we don't know what it is and what is there. What we see that the objects are coming together to a place, but we don't know what's causing it. So that's what we call all these dark gravity, dark energy. And the dark energy is making the universe expand, the universe's expansion accelerate. So it's also effect. The universe's expansion is accelerated, but uh, why it's being doing so, we don't know. That is why we call it dark energy. So the same goes for dark gravity and dark energy, dark matter. So is that all? And for and another question is when the sun would stop to give us energy. So our sun is a medium-sized sun, is a medium-sized star. So it's about now in his half age. It has some 4 to 5 billion years more to go. So yeah, in 4 to 5 billion years, the sun would actually be uh, in the last stages of its life.
Right. All right. So, the first one, in the first you said that that the dark energy is responsible for our expansion of universe. Am I right?
Yeah. Mhm.
Okay. Okay.
Yes.
Okay. Thank you.
Okay. Thank you.
Next question. Yes.
I have a question.
Yes.
Yes.
Um, Acha, can you tell me more about the purpose of the James Webb telescope? As in, why does it focus on infrared? What does infrared को देखने से what benefit do we get other than, more so than looking at visible light?
So yeah, visible. So the infrared, as we can see here in the electromagnetic spectrum. So light takes time to reach us. So visible light, as the wavelength of the infrared is greater than the visible light, so what the source of the infrared waves is further back from the light which is visible. So when we see the infrared radiations, infrared spectrum, infrared from where the infrared waves are coming, so it's further back from where the visible light is coming. So what it means is that through James Webb, we can see further back in time than we had previously done. So Hubble saw the visible, which is what we can see with our naked eyes through telescope, obviously. So infrared is beyond what we see through Hubble, and it is further back in space, further back from where the universe was formed. So yeah, infrared is, uh, uh, as I have said, that it is further back from the visible spectrum. So yeah, is your question answered?
Yes, thank you.
Okay, thank you.
Next.
Can I ask a question?
Yes, Hasnan.
Wasil, at one point of your presentation, you said that looking into a distant stars in at sky is just like looking into the past life of this universe. Can you please explain this point a bit to me?
Yeah. So you understand that light takes time to
Sorry, I
reach.
did not understand the question. What was the question?
Ma'am, my question was that at one point he said that looking into a distant star is just like looking into the past of this universe, life of this universe.
Uh-huh.
So I asked him, can you explain a bit to me in detail?
Yeah, can I answer?
Yes, please.
So as you understand that light takes time to reach us. So in our daily life, we don't observe this effect as the distance. For example, I'm sitting in a room, and I see stuff. I see walls. I see a chair. So why I see that is because the light reflects on that object, and the lights reflect back to my eyes. Is why I see these objects. But when we talk about the universe, the cosmos, the light from these stars, from these galaxies, they are also coming. I will see them when they reach my eyes. So when they reach my eyes, as the universe is immensely large, even light takes time to reach Earth, to reach our eyes. So that is why when we see the light coming from further galaxies and stars, we see a light that was, for example, a star is 3 light years away from Earth. When we see that star, the light of that star coming to us, the light, what we see is 3 light years old. You understand that? So when the light was formed, when the light left that star 3 light years further, 3 light years back, 3 years back, uh, that light was traveling through the space, and when it reached after 3 years, we saw it at that time. So light takes time to reach us. So when it reaches is when we observe it. So yeah, is your question answered?
Yeah, so this means that if someone lives at Jupiter, when he sees on Earth, he's basically looking into the past.
Yeah. When you see the moon you are looking some seconds back. When you're looking at the sun, you are looking back 8 minutes and 42 seconds back in the past, back in time.
Okay. Thank you.
Thank you.
Okay, so that was interesting. That was very interesting. Thank you, Wasil.
Thank you, ma'am.
So for everyone, you can further explore this. This is chapter 19 of Crane. Okay.
Okay, ma'am.
Yeah. So, these presentations and these papers gave us an opportunity to explore topics again, which are in Crane, but they could not be a part of the class content, right? But now you see these are advanced topics in nuclear physics. So there are many advanced topics in nuclear physics that you can explore, and we've explored some of them as papers and presentations. So one student has done the effort to collect this material and to present this material to us, to study the material and answer your questions. And since I'm uploading these presentations, so it becomes a part of the course syllabus, and it gives you a chance to explore these topics as well, right? So I think it's a very useful exercise for all of us, including the student who prepared it, and then the rest of the students who can ask questions and who can also benefit from that. So that was very nice, Wasil. I also saw that you included a brief history of time in your preparation material. So have you read this book?
Yes, ma'am, I have.
कब पढ़ी है? अभी या have you read it before?
No, ma'am, I have read it earlier, so it helped me a lot now as well.
Yeah, that's very nice. I would recommend all of you to read this book. It's a very nice and interesting book. In fact, it's one of the most popular physics books, and you don't have to be a physicist to read it, Hannah. It's written very simple. It's
Very,
written,
very simple.
huh?
That it's very simple. That is the good qualities of Stephen Hawking, that he writes that everybody can understand it.
Yeah, it's understandable for everyone. Even if you're not a physics major, you can still understand it. So everyone should read this. बाकी लोगों ने पढ़ी हुई है ये book?
मैम मैं वेटिंग लिस्ट पे है लेकिन अभी पढ़ी नहीं है।
Waiting list में रखना.
मैम वो कुछ
Also,
मैम कुछ बुक्स हैं वो वेटिंग लिस्ट में, वो टाइम नहीं मिल रहा अभी।
Yeah, you develop a habit of reading rather than scrolling social media. I know it's very distracting. Social media has actually affected our reading habits. Reading habits lead to further brain development, whereas scrolling the internet is actually bad for our brain and for our reading habits and all that. You lose your focus. They're very distracting, you know. By scrolling around on social media, we actually lose our focus ability, our concentration ability. So
You are right, ma'am.
yeah, try to minimize the time you spend on social media and try to get back to books. They can be a great source of leisure as well. Okay, so you can look at them in that way. And this is a very simple book. Don't read it as something for getting a grade. Rather, it's something for enjoyment. Okay. So that was very nice, Wasil. Wasil, you know that you were talking about the expanding universe. There's a Nobel Prize about this as well, Hannah. Just recently, there was a Nobel Prize on this topic, Hannah, when it was confirmed. Can you talk about that a little bit?
Yeah, yes, ma'am. I haven't. I saw it, but I can't remember who was that.
No, you don't have to remember the name. Just tell us briefly about what the Nobel Prize was about, and that's it. You don't have to remember the name of the scientist.
So it was about, I think, that generally was expansion of the universe, but I can't remember, ma'am, actually.
That's okay. Anyway, I would recommend all of you, like the Nobel Prizes are always an indication of some very good work that has happened in the field of physics in this case. And again, the Nobel Prize website gives you information at a very simple level, which is called the popular level. Popular level means it's for everyone, even for non-physics people. And then if you want to explore further details, then they give this scientific links as well for people who want to explore further. So, and then as you know, the Nobel Prize is a very famous prize. It's the most prestigious prize we have in this field. So therefore, it gets a lot of focus by many people, and you get a lot of material and it becomes, and it's verified by many people. Like one of the criteria of Nobel Prizes is that it has to be confirmed theoretically and experimentally and so on. We've talked about that several times before. So I would also recommend you guys to look at that. In Crane also, in the beginning, you have a list of major achievements in the field of nuclear physics. But of course, it does not add the recent prizes, because of course the book was published up till a certain date, and then the more recent prize, Nobel prizes, you can check them up on the internet, right? Okay.
Yes.
Yeah, so these are all very interesting topics, and again, like I said, they come in popular media, which means they're just not for physicists, but they are for everyone. But you being physicists, you can explore these topics further, right? Okay, and then I also appreciate the point that you used videos to illustrate your concepts. That was also very helpful. So you made a good effort. And on the whole, I think it was a very good presentation. So thank you, Wasil.
Thank you, ma'am. Thank you.
Okay, so now I have to make some announcements regarding this course, and I would like to share my board.
Ma'am, should I stop screen share?
Yeah, you can stop. No. Okay, so let's see. So you can see the board now.
Yes, ma'am.
So what you can see on the board is your assessment plan, right? Which is already shared on Moodle, right? It was also shared in class several times. So here you can see that we have finished with these, right? And now what we have to do is this, right?
Yes, ma'am.
Okay, good. So for this, the final exam syllabus, like a student was asking me last time, Meka Sarfraz was asking me. So let's include nuclear reactions. Okay. This also includes the topic of nuclear cross sections. And it includes alpha decay, beta decay, and gamma decay. Okay?
मैम बस यही है
और बढ़ाएं?
नहीं मैम ठीक है मैम प्लीज मैम एक और भी बात थी हम मैम कल सारे आपस में डिस्कस कर रहे थे
क्या
मैम हम थर्सडे को एग्जाम स्किप करके ट्यूसडे को ना कर लें
क्यों
मैम वो एक तो 2-3 प्रोजेक्ट्स हैं फाइनल और मैम थर्सडे को एक और फाइनल है
कौन सा फाइनल है
मैम कंपैरेटिव रिलीजियस स्टडीज का
वो किसका
मैम कंपैरेटिव रिलीजियस स्टडीज 401 इस्लामियात
वो किस स्टूडेंट का है ये
मैम ये मेरा है और मैम 16 को हम सब की प्रेजेंटेशंस हैं
आपको मसला है
सॉलिड स्टेट फिजिक्स की मैम प्रेजेंटेशंस हैं हम चारों की हैं सॉलिड स्टेट फिजिक्स की और फाइनल जो 17 को है ना वो सिर्फ मेरा है
आप अब क्यों बोल रहे हो आपने पहले क्यों नहीं बोला जब हम डेट सेट कर रहे थे मैंने तो आपको बहुत पहले बता दिया था बाद में
वो
चेंज करना कैन बी अ प्रॉब्लम
मैम आई नो मैम, सर ने अभी लास्ट क्लास में बताया है और प्रेजेंटेशन भी मैम ने सेकंड लास्ट क्लास में
हसनैन सिर्फ आपका प्रॉब्लम है, सो आई डोंट थिंक कि पूरी क्लास का हमें चेंज करना चाहिए फॉर दिस पर्पस. ओके, सो लेट मी कंटिन्यू. आपकी प्रिपरेशन के लिए यू ऑफ कोर्स हैव द क्लासेस जो हुई है ऑन कैंपस, राइट? क्लासेस जो हुई है जूम पे, और उसके अलावा यू हैव द यूट्यूब लिंक्स, यूट्यूब रिकॉर्डिंग्स जो मैंने अपलोड की है. I'm not talking about any random YouTube recording. I'm talking about the recordings जो मैंने खुद अपलोड की. Is that clear? आप लोगों ने देखी है? Have you seen them? कौन
यस मैम.
प्रिपेयर हो गया है?
मैम अभी कंप्लीट प्रिपरेशन नहीं है.
Hasnan, you have a very low attendance in the course, है ना? क्यों? क्या मसला था आपका? क्या
मैम
आपकी
कुछ
this is how you study, this is your style.
नो मैम इस सेमेस्टर में पहले मामू थोड़े बीमार थे, तो बाद में जो है इसके बाद थोड़ा कोविड हो गया, तो उसकी वजह से.
Okay, so Hasnan, if you cannot give the exam on Thursday, so I can consider that as a personal request from you. लेकिन class का schedule remains the same. Is that clear?
ओके मैम.
So बाकी सबके लिए I think it's very clear. The syllabus is clear, the dates are clear, and again there's nothing new in this. This is what we've decided from the very beginning, है ना? ये वही चल रहा है ना हमारा सारा schedule.
यस मैम मैं भी वो स्केड्यूल को ना बड़ी अच्छी तरह फॉलो, लेकिन इस पिछले वीक में कुछ ऐसे इवेंट हुए हैं, उसकी वजह से डिस्टरबेंस काफी आ गई थी स्केड्यूल में.
अच्छा हसनैन, I've talked about it with you. I want to know बाकी students के बारे में. Is that everything clear to all of you?
Yes, ma'am.
You're okay, right? So, what about you, Sam? तुम्हारी तैयारी है?
मैम मेरे तक जो है वो सारी है मैम.
हाँ जी.
मैम मेरे तक जितना पड़ा था वो सारी. मैम आपने न्यू जो प्रेजेंटेशन वाले वो सिर्फ मैंने गो थ्रू किया, वो उसकी तैयारी करनी है मैम मैंने.
वो YouTube वाले बीटा और गामा डीके का आपने पढ़ा है अच्छी तरह से?
वो मैंने डिफरेंट सोर्स से पढ़ा था. आपने जो मुझे सेंड किया वो मैंने नहीं किया मैम.
उस पर भी पढ़े, ठीक है. ओके, एंड हु एल्स? वासिल, आपकी तैयारी कैसी है?
मैम वही मिड तक सही है, बाकी फिलहाल आगे नहीं किया था.
तैयारी इज अ प्रोसेस, यू नो, लर्निंग इज अ प्रोसेस. एक दिन में नहीं आप कर सकते, एक रात में भी नहीं कर सकते, ठीक है. सो माय एडवाइस इज कि प्रॉपर अपना टाइम टेबल बना के उसको कंटेंट को आप प्रिपेयर करें प्रॉपरली, ताकि आपका अच्छा ग्रेड आ सके. इज दैट क्लियर? स्टडी सेट असाइड अ नंबर ऑफ आवर्स जो आपने उसको बैठ के पढ़ना है प्रॉपरली, कंसंट्रेशन के साथ, विदाउट एनी सोशल मीडिया.
यस मैम.
ये यू हैव टू डेवलप दिस हैबिट ऑफ स्टडिंग विदाउट सोशल मीडिया. ये बार बार फोन को चेक करना या सोशल मीडिया को चेक करना से आपका फोकस, आपका दीज आर साइंटिफिक स्टडीज दैट शो कि आपका फोकस और कंसंट्रेशन डिस्टर्ब हो जाता है, तो फिर आप प्रॉपरली पढ़ नहीं सकते, ठीक है ना. सो देयरफॉर आई वुड एडवाइस यू कि अभी भी कुछ दिन हैं, आप प्रॉपरली इन टॉपिक्स को प्रिपेयर करें. इज दैट क्लियर?
क्लियर मैम.
एंड द डेट रिमेन. यस,
17 को मेरा मैम क्विज है मैम, डिफरेंशियल ज्योमेट्री का.
ठीक है. हमारी डेट इज नॉट गोइंग टू चेंज बिकॉज आपके, मैंने ये शुरू से अनाउंस की हुई है डेट, सो यू हैव टू एडजस्ट योर टाइम टेबल अकॉर्डिंगली. मैं क्लास के टाइम में ले रही हूँ, सो दिस इज द स्लॉट दैट वी हैव. ओके, तो इसमें कोई प्रॉब्लम नहीं है, ठीक है.
वो मैम ये पर्सनली आप लेंगे एग्जाम?
हाँ
ये मैम पर्सनली लेंगे एग्जाम आप?
it's 1-to-1. I'll have a Zoom meeting with each one of you individually, and वहां पे I can ask you questions and you can answer them, you can explain them. आप पेपर पेंसिल अपने पास रखनी, so that if I ask you to write something, you can write something. Okay, clear?
ओके मैम.
अकेले बैठना है कमरे में without any materials with you.
ऑलराइट.
Okay, all the best.
थैंक यू मैम.
Here,
ओके मैम, अल्लाह हाफिज.
Ma'am.
Allah Hafiz.